Alrighty, so now we're going to use some of this trigonometry stuff that we use. Remember that stuff? That thing called SOHCAHTOA that we loved? Remember that? SOHCAHTOA? We love it. So we're going to use that now in a little bit of like an application type of thing. You know, these are like the real world stuff, the word problems and things like that. Really, there's a lot of opportunities to use this stuff. So let's check out a couple examples. First of all, outside the school, Erin was trying to use a protractor to measure the angle of elevation. Ooh, big word there, angle of elevation. What does that mean? We'll talk about it. So basically, we realize that from where she's standing, if we can draw a picture of what's going on here, let's see, she's standing 17 feet from the base of the flagpole. So we need a flagpole. Okay, so it kind of looks like this. Here's my flagpole, da 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 da. There's the stars and there's the stripes. Yay, God bless America. Okay, so here's the deal. Erin is standing over here. Okay, there's Erin. She's got nice long hair. And she's holding that protractor in her hand. We'll model it a little bit better. She's standing on the ground, and the angle of elevation is the angle that you look up at something. So that angle from the ground up to where you might view the top is 58 degrees. She's standing 17 feet from the flagpole. So here's 17 feet away. And the question is, how tall is the flagpole? So remembering that SOHCAHTOA thing, over here I got the opposite side. I got the adjacent side. That's going to be tangent. So I can write the equation tangent of 58 equals opposite over adjacent. Okay, so when we write this equation and solve it, remember when the variable's in the sky, we're going to multiply. So we're going to multiply 17 times the tangent of 58, and that's what h is going to be. So remember, if you're doing it on your phone, what you're doing is you're typing 17, you're typing the multiplication button, you're pressing 58, then you're hitting the tan button, and then you're hitting equals. And when you do all that, you should probably get that h is about 27.205. I'm looking at my calculator. So let's say it's about 27 feet. That might be a good value. I would tell you what to round to. I'm not worried about the rounding. I'm worried about you being able to write a trigonometric equation and solving it. So new vocab, angle of elevation. Let's keep rolling. So another scenario. Dr. Intrieri, she's always looking for illegally parked cars. And she sees one way up from the roof all the way down to the parking lot. So let's draw a picture of what's going on here. Okay, so like here's the school building. There we go. And here's Dr. Intrieri. She's up here. She's got her long hair. And there's some car that's parked way out here. Oh boy, that's a really, really bad car. Looks like my car. It's a Rolls Canardly. It's the kind of car that rolls down one hill and can hardly make it up the next. Okay, but here's the deal though. She sees an angle of depression. So the angle of depression is when you're standing up and you look down to something. That's the angle of depression. So you have an angle of depression, you have an angle of elevation. Now notice that the angle of depression is really the angle from this line of sight. Let's say that is how you're looking horizontally. The angle of depression is this angle here. Notice that the angle of depression is not an angle that's in your triangle. But notice that the line of sight is a horizontal line. Let's assume that the ground is flat, it's horizontal. So the line of sight is parallel to the ground. And therefore, the angle of elevation is the same as the angle of depression. Okay, that's a big thing to remember, is that the angle of elevation is the same as the angle of depression. They're the same things. So keep that in mind if you have an angle of depression. Now we're told that her eyes are 55 feet above the ground, and we want to know how far away is the car. Let's call that distance D maybe. So if I'm looking at this, based on this 27-degree angle of elevation. And again, I'll use the angle of elevation because it's in the triangle. My 55 is my opposite side. My ground is my adjacent side. I'm using tangent again. So let's do the tangent of 27 equals opposite over adjacent. When the variable's in the bottom, you got to divide. So I'm going to just kind of switch these two terms around. I'm going to put my d on the side with the equal sign, and I'm going to do 55 over tangent 27. So when you grab your phone, you're doing 55, you're dividing by, you're typing in 27, and then you're hitting your tangent button, and then you hit equals. And when you do that, you should get that the distance d is about 107.943 and a bunch of other numbers. So can we call it 108 feet? Let's do that. We'll call it about 108 feet. Cool. So now you know angle of elevation, and now you know angle of depression. Doing good. Doing good. Have you ever leaned a ladder against the wall? Yeah, it's a pretty common question here. So a carpenter leans an extension ladder against the house to reach the bottom of the window that's 30 feet above the ground. So the height of the window there is 30 as it shows in the picture. And the ladder makes a 70-degree angle with the ground. So there's my angle of elevation for the ladder, 70 degrees. And we want to find out the length of the ladder, which is kind of like a ridiculous question anyway. Because if you think about it, you know what the length of your ladder is. You have like a 20-foot ladder or a 30-foot ladder or a 40-foot ladder, and you want to know the height of the building or how high up how far away from it is. These word problems, terrible, but good for geometry. So if I'm looking at this triangle here, it looks like the ladder is my hypotenuse. The 30 is my opposite side. If I think about SOHCAHTOA, then opposite and hypotenuse is sine. So the sine of 70 equals the opposite side over the hypotenuse. So if we solve this equation, we're going to end up doing some division because the variable's in the denominator. So x equals 30 divided by the sine of 70. Go to your calculator, type it in. So you're going to do 30 divided by 70, type sine, hit equals. You should get that x equals 31.92. So let's say the ladder's a 32-foot ladder. That might make sense. Now, as much as this question was kind of like fictitious and made up and stuff, our final one is a real-life thing. If you're making a handicap access ramp, the slope of it, the steepness, has to be 1/12. So every time you go up 1 inch of height, you have to go 12 inches of horizontal length. This is a national rule. Otherwise, if you had somebody who had a mobility situation, whether they're in a wheelchair or a walker or a cane, it would be too steep for them. So they do make them with what's called a 1/12 slope, which means that for every time you go up 1 inch or 1 foot, you have to go 12 inches or 12 feet or something like that. So if you have to go up a step that's like, say, 2 feet high, which is 24 inches, you have to go 24 feet out. Long ramp. And what we want to know is what's the maximum angle the ramp can have. It can be lower than that, but it can't be more than that. So I'm looking for the measure of my angle. What if I bring back my variable theta? Remember that variable? We did that a long time ago to measure an angle. Sure, so we want to find the maximum angle of this. So again, I'm looking at my SOHCAHTOA. I have 1 is my opposite, 12 is my adjacent. I'm doing tangent again. So this time the tangent of my angle theta is going to be 1/12. And you might remember from your practice that to find the measure of the angle theta, you have to do the inverse of the tangent function. And that looks like this. Inverse tan of 1/12. So on your calculator, you're going to first do 1 divided by 12, press equals, get that decimal, and then you're going to do the second function, and then press your tan -1 key. And when you do all that, you should get the angle to be about 4.76 or so degrees. So the national standard set by the American Disabilities Act says that the angle has to be at most 4.8 degrees. That's the steepest the angle could be. So some pretty neat things there. Hopefully you got a little extra practice with trig. Like I said, it's one of my favorite things. I wish I was with you to do this stuff.